Good evening, everyone. It's me again. I'm Lena, and I'm from the Healthcare Landscape Group. In this video, I'm going to be talking about my third day edition, which is on the number 30, part 3. So in this video, I'm going to be solving the 5 main problems that Mrs. Prout sent out for us to do in our third daily edition this week. So let's get started on our first part. So the first problem, Mrs. Pratt said that prove that 8,648,032 is not a multiple of 8. Now, I've found this claim to be, I've disagreed with this claim and that this statement is false because 8,648,032 is a multiple of 8. Why? Well, according to the divisibility rule of 8, the last 3 numbers must be divisible by 8, which is 32. So 0 and 32 is actually 32, and 32 is divisible by 8 without any remainders. And if we calculated this whole number, it will be divisible by 8 with no remainders. So this is a multiple. This number is a multiple of 8. The second problem. The second problem is please write the 4 numbers, these 4 numbers, as sums of multiples of 8. So we are going to write these 4 numbers as sums of multiples of 8. Now, it's easy. It's just easy. So we have 8,024, and this will equal 8,000 plus 16 plus 8. Or we can say 8,000 plus 24 because those two are the multiples of 8 and they add up to 8,024. Same goes with the second one, which is 168,640. This will equal 168,000 plus 80 plus 80, and these are all multiples of 8. Next, we have 72,032, and same goes with that. 72,720,000 plus 32. These are the multiples of 8. Finally, we have 64,856. So we'll break this down. 64,000 is a multiple of 8 because 64 can divide by 8 to make 64 we can divide by 8 to make 8, and with the trailing zeros we have 8,000. And then we have 800 plus 56, which makes 64,856. The third problem, prove that 35,100 equals 2 to the power of 2 times 2 to the power of 3 to the power of 2 times 5 to the power of 2 times 13 to the power of 1. Now, break this down. I'll break this down one by one. 2 squared will equal 4. 3 squared will equal 27, and 5 squared will equal 25. 13 to the power of 1 will equal 13. And if you look closely at the numbers, you can see that 4 and 5, 25, add up to times multiply together to make 100. So we'll put those 2 in parentheses, and these two numbers make 351. Therefore, 351 times 100 will equal 35,100. And that is my answer for problem number 3. Problem number 4. The prime factorization of 392. So 392, what is its prime factorization? So its prime factorization, let's break this down. 392, let's divide it by 2. Divide by 2, 1, 2, 19 is 9, 196. Divide by 2 will equal 196. 196 divided by 2, 98. 98, 2, 98. So this goes on and on and on. So we will break that down to 2 times 2 times 2 times 7 times 7, which equals 2 to the power of 3 times 7 to the power of 2. So that is the prime factorization of 392. A, please fill in the blanks so I don't have to write this. We'll fill in the blanks, 0 in 0. So B, if x2 to the power of x times 3 to the power of y times 7 to the power of z equals 392, y will equal what? Now let's see from the first part that Mrs. Pratt gave us for problem number 4. So the prime factorization, we found that 2 to the power of 3 times 7 to the power of 2 equals 392. So there won't be a 3 in there. How can we ensure that there won't be a 3 in there and to make it still 392? Well, the y must be 0. So 3 to the power of 0, 3 to the power of 0 will equal 1. And 1 times 392 will of course equal 392. And if y equals 0, x times y times z, all of these 4 exponents, will equal 0 because y is 0 and any number times 0 equals 0. So that is problem number 4. Let's solve problem number 5, the last problem together. Let me clear this board so I can get some space to do problem number 5. Alright, so problem number 5. I'll show you the problem. So problem 5. There are 60 seconds in a minute, and we know that. Light 1 will flash every 1 minute and 50 seconds. Light 2 will flash every 60 plus 40 seconds. The shortest time that those two lights will elapse or flash together will be after how many seconds and how many minutes. So let's break down this problem together. Light 1. Light 1 flashes every 1 minute and 15 seconds. Let's transform it into seconds. So 1 minute and 15 seconds will equal 75 seconds. Next we have 60 plus 40 minutes. 60 plus 40 seconds, and this will equal 100 seconds. Now, the problem says that the shortest time that those two lights will elapse or flash together will be after how many seconds or how many minutes. So, looking at this problem, I know that this is I must find the least common multiple of 175. LCM of 175 will equal 300. And the units is seconds. How can we transform this into minutes? Well, 300 divided by 60, which is 60 seconds in one minute, will equal 5 minutes. So answer is 5 minutes or 300 seconds. That is my answer for problem number 5. And that is the end of my third DE this week. I hope that you learned something new from this video or just review some of the things that you have learned. Thank you for listening to my video, and I'm glad to hear any of your suggestions for improvements and any questions that you have on my video. Thank you again for listening to my video, and I hope to see you in the next meeting or the next video. Goodbye, see you later.